I'd like to welcome Sudhir Tonse. He currently leads the data platform engineering organization at DoorDash, where he focuses on building the right data architecture that enables DoorDash to make timely, informed, data-driven decisions. Sudhir is here to talk about the challenges in defining and achieving higher data quality standards. Thank you so much for joining us today. Take it away, Sudhir.
Hello, everyone. It's wonderful to be here today at the Data Reliability Engineering Conference 2022. I'm Sudhir Tonse, and I lead data platform engineering at DoorDash. I've been here for a couple of years, but I'll get more into my work later on as we talk through the session. Without further ado, let's see why we are here today. I want to just call out that reliability of the web services or the microservices world has been a part of the industry for a while now, at least a couple of decades or more. And multiple companies have looked into it differently, but one of the more famous ones is from Google when they published the Google SRE principles, which has been codified today into books and various articles. How do we take that to apply to the world of data or the big data domain is what we'll be focusing on today as far as the conference goes. And this particular talk will focus on one aspect of that principle called setting standards, but we'll get there. First, let's try to figure out what we mean by the big data domain. Well, this is what we essentially mean, right? Data in most companies, when we talk about big data, it's about the volume of data. Many companies, similar to DoorDash, have got petabytes of data, or some companies got even more. So you could talk about data in terms of billions of records that you may have, thousands of data sets you may have. And if you're processing message from a real-time streaming perspective, you would be talking about billions of messages or events that you process on any given day. So all of that's data, right? And excuse my cough for a little bit. All of that's data. However, data in and all by itself is not terribly useful until you convert them into information. And again, information itself is not terribly useful until you figure out how to gain insight from that information. How do you then figure out what you do? Are they actionable? I'll give you an example of DoorDash, right? Yes, you've got a lot of operational data, but an information and insight is something like, hey, as far as supply and demand goes, and supply in our case is the number of drivers, dashers available to deliver. Demand are the consumers like you and me ordering food or other items through the marketplace. If there is an imbalance in supply and demand, that's an insight. Well, if that imbalance was detected as of yesterday, well, it's not actionable. Well, too bad. We can learn from that, but nothing much I can do as of now. However, if I were to predict that sort of an imbalance, half hour from now, a day from now, a week from now, in that time horizon, well, there's something I can do about it, and that's actionable insight. But to do all of these, to make sure that you get actionable insight and some impact from that, data has to be reliable. And most companies go through this thing called as a OODA loop, which is observe, orient, decide, and act. You observe the tons of data coming your way. You orient yourself. You figure out. You compute the data. Look at insights. Then you decide whether it's actionable or not. Sometimes programmatically, other times with the human in the loop, and then you act on that. And this loop just goes on. It's the OODA loop. Coming to data reliability, then, what ails us as a data organization, as a data community, is oftentimes data has got issues. There are outages. Simple examples include data is at the backbone of how companies define their earnings report, their SEC filings as they're going into IPO. Oftentimes it's about predictions you're going to make about the market. And most companies that are data driven use experimentation or A/B tests to launch features. Each of these could be erroneous, have issues, have outages. And in some cases, it's as dire as your CFO being in trouble, could be jailed, right? You don't want that. You don't want to launch incorrect features in your marketplace, which is going to dent your bottom line and your top line, which all leads to loss of trust in yourself, in the organization that you're part of as a part of a data community. How do we prevent this, how do we prevent this irreliability issue and gain trust is what we're talking about today, right? So yeah, why me? Why me for this talk? Well, because I've got a couple of decades of experience, and the last, I guess, 7 to 8 years of them have been very focused on the big data domain. And I've had a share of my outages or two, some of them pretty large, especially the one that I remember from my previous job at Uber, where we detected some experimentation data that was erroneous and had issues way late than we were supposed to, which caused us a lot of heart grief and a lot of heartburn. So that's why I'm here today. I care about this field a lot, and listening to all the other speakers, listening to the industry folks on how they're dealing with this is super interesting to me, and I can share some of the stories that I've had. So yeah, what are DRE principles or data reliability engineering principles? Again, borrowing from the SRE guidelines or the SRE principles, there are about six. Embracing risk. Outages are going to happen regardless of what you wish. It's not something you can prevent. However, while we are embracing that risk, we got to be ready for that risk. Reducing toil, you should reduce the number of manual steps involved, automate your way. You should monitor everything that's in your pipeline. You should control your releases. You should know what's going on. You should be able to detect issues as soon as they happen. And what I'll be focusing on today is the second principle, or setting standards. So what exactly is setting standards? And I'm going to put data, focusing on the data aspect of set standards. Well, it's very crisply defined. It's wonderfully defined. If just let's take a pause and go through that for a second. When someone depends on data, it's wise to clarify what exactly they can depend on with clear definitions, hard numbers, and clear cross-team agreements. Each of these words are super important in this crisp definition. So let's go through them and see what they mean. Someone, what's someone? Who's someone? If you're part of a data organization or a company that relies on data, we got to understand the data ecosystem. What are they? Well, they're the builder community. These are the folks that are actually building the data that's then consumed. These are your data scientists, your machine learning engineers, your data analysts, poring over dashboards, looking at week over week trends, your data engineers that are building models that are suitable for consumption by the data analysts, by the machine learning engineers, etc. These are the builder community. And you would have a technical stack behind them. And if you're a data platform organization, which is what I lead, then you're responsible for each of these entities, each of these personas. On the other hand, there are data consumers. These are your business leaders, your CFOs, your product managers, your operators on the ground. These are the folks that are actually consuming the insights that your organization has developed and making decisions based on that. So it's very important to understand that someone. Who is that someone that you're catering to? And then it's about a question about defining data contracts. So you got to measure what matters to us. In this case, the happiness, the satisfaction of this community of data builders, data consumers, etc. So again, revisiting that concept, it's about essentially boils down to data contracts. How does one create one? So let's get into that. In the industry, the most popular way of defining data contracts are through this concept of SLIs, SLOs, and SLAs. Now, what are these? Let's get into some of these. SLIs. SLIs are service level indicators. They usually measure a specific part of the data quality ecosystem. For example, hours passed since the last data was last refreshed. And if you got a data sets with many columns, for each of those columns, what's the percentage of non-null value that you expect? If Snowflake is your data warehouse, what is the P95, P50 queries time taken? If you're into provisioning new clusters as a data tech stack, how long does it take for you to provision something like a Presto or a Kafka topic or something? If you're running an experimentation platform, what's the total amount of time it requires you to run experiments and analyze them specifically? So those are SLIs. The data quality attributes are pretty well known in the industry. They go with timeliness, completeness, duplicacy, accuracy, etc. The definitions, it's too much to go into this particular talk, but it's kind of well known. So for example, timeliness, let's just focus on that one aspect. Most times I've seen this opposite, as in engineers say, hey, I can run my ETL pipeline once every 12 hours, and that's their SLA. Well, that's sad. Here's why. If you're a global organization, you got operators that depend on that data at different time zones. You got to understand what they need. If they're looking at a dashboard and it's already 12 hours old, it might be too late for them. So you got to understand what timeliness means for them. So each of these attributes are super important, and we have to understand what our end users care and what it means to them. Duplication of data might be okay for a machine learning use case, might be okay for an exploratory ad hoc use case, not so much if you're reporting this for your investor report, right? So each of these have got plays in them in terms of a range of acceptable values, and you have to figure out what's right for your use case. So that's where SLOs come into play. SLOs are objectives. So for each of the indicators that we talked about previously, we allocate a certain range. We say that the P50 or P95 query performance for ad hoc queries in Snowflake is going to be in the range of 3 to 200 seconds. We talk about how long it's going to actually take what we expect to provision a cluster, etc. So those are SLOs. So then we'll focus on the last part of the setting standards, which is agreements or SLAs. How do we reach agreement on these hard numbers that we just discussed with our data personas? So for that, first define each of our data services. It's a combination of use cases that you have: a machine learning use case, an experimentation use case, a company's dashboard or a business KPIs use case. They're all different use cases, and it's your aim to figure out what the SLOs for each of these use cases are. So some of those are listed out here. And then you come out with a formal document. Now, this is true if you are a data SaaS-like operation, which is if you're talking about Databricks or Segment or Amplitude or Snowflake or any of these sort of organizations, you have to come up with a formal agreement towards your customers, and that gets pretty involved. There's a lot of templates available over there to see how one structures an SLA document. However, for most people, you are an internal organization, such as myself. I'm a data platform leader for DoorDash. You can either concoct a bunch of agreements, metrics, dashboards, and alerting, or you could also go with a vendor such as Big Eye, right? And they've got a wonderful interface wherein you could define your metrics, your SLAs, you could look at your data catalogs, etc. So again, revisiting SLAs, it's how you define your metrics, your objectives, and what needs to be met as your target, and then religiously following through them with your dashboards and alerting mechanisms, right? So that, in a nutshell, is what this whole thing is about, which is setting standards, setting data standards. So we talked about the someone, your data personas. We talked about clarifying what they really, really need with hard numbers. And we talked about getting an agreement and then following through with that agreement. Well, now that we've defined it, it's taken us 10 plus minutes just to define what we want to do. How do we get there? What are real things we should focus on as data practitioners? Let's take the rest of the session to go through that. So the first thing that comes to mind as far as my experience goes is every company has sort of evolves into a complex architecture. And the first thing we want to do is to simplify your data pipeline architecture as much as possible. Let's talk through some of this. If you look at an infographic of a big data ecosystem, and this picture that I've captured is from 2016. Can you imagine what 2022 looks like, especially with all the VC funding, etc.? So it's huge. It's huge. A typical organization's data workflow or a data pipeline ecosystem looks like something on the right-hand side there. It's an eye chart, of course. But the point here is that for us to reach reliability, the more technical solutions that you add into an ecosystem, the harder it gets to define or to have good data reliability. So for example, here's an example of one particular small little pipeline. It's about how do you build real-time metrics and dashboards. And this is prior to me arriving at DoorDash. There's a monolithic application which sends telemetry data to UDP server, which is then sent to Amazon's SQS, which is consumed by an SQS consumer, which is then sent to Amazon Kinesis, which then sends the data over to Amazon S3 for storage, which then through Snowpipe goes to Snowflake, and out comes a dashboard in Tableau, or in our case, Sigma right now. Okay, complex. Assume that your consumers are complaining that the data is not fresh. They're looking at the number of deliveries, they're looking at the number of orders, they're looking at a certain set of metrics, and it sounds like it's not keeping up to the actual reality. How do you debug this? It gets super hard because the number of components involved here it's hard to pinpoint exactly where the delay happened. So complexity of a data architecture matters more. I'm a big fan of this particular blog here called Boring Technology. Here, Dan is the author of the blog. He talks about an interesting problem. A data organization, for example, has to solve a bunch of problems, whether it's a machine learning use case, experimentation use case, business reporting use case, and we've got a set of technology choices to make. Many companies seem to just go as like, hey, I know how to work on Redis. It's my caching solution. Let me add it. I know how to work on XYZ. Let me add it to the ecosystem. So for each of the problem set that you have, if you keep adding more and more technology to the mix, exceptionally, for example, if you were to add redundant technology, streaming comes to mind. If you have Kafka plus Flink plus Spark Streaming plus Apache Beam plus etc., well, that's a little too much. It has a problem in terms of cost, total cost. It has a issue in terms of the velocity, and it definitely has an issue when it comes to data reliability, because the more complex your architecture, the harder it is to achieve data reliability. It's harder it is to define SLIs, SLOs, and SLAs, because there's too many areas to look into and too many SLAs to define. A typical architecture in most companies, and this is somewhat true at DoorDash, is in order to build this insight that we talked about, you get data from your transactional ecosystem. There could be MySQL, Postgres, Cassandra, CRDB, etc. Most companies also have real-time telemetry data coming in. If you go to your mobile app or your website, when you're adding items to your shopping cart, when you're checking out, when you're searching, discovering, browsing, etc., these are all activities that come in typically through a message or a PubSub ecosystem such as Kafka. And there's a series of ELT or ETL that happens to convert that from raw data to a data lake, to a data warehouse, data mart, aggregate data, etc. Well, how many technologies can you add into this mix? Spark, Flink, Airflow, Lambda, Pinot, Amplitude, Databricks, etc. Right? So all of that matters. And my suggestion, what I've learned in life, is to figure out how to simplify your data pipeline architecture, question every addition, so that we know that they are reliable and we are focusing on reliability and simplification of the overall architecture. Second, it's not all about, I know we talked about petabytes of data, thousands of data sets, billions of messages processed. Well, guess what? They're not all important. Most companies figure out what's the right scope that they should focus on when it comes to reliability. For example, in most companies, you may have thousands of dashboards, but you identify a top 10 dashboards that are really important. You may have tens of thousands of data sets or tables, but you identify the top 100 or so. We call them golden data sets. Metrics, similarly, you may have thousands of metrics, but you can't focus on all of them. Focus on the right top 100, top 10 KPIs or metrics. Similarly, machine learning models, experimentation, et cetera, et cetera. You go down the list. Again, the idea here is that, yes, you got a heap of data, but they're not all equally important. Filter them, figure out ones which really, really are important, and define the right scope for your data reliability. Well, that's the second lesson that I would like and that I've learned. Third is to invest in the right data quality framework. Now, this question about data observability, data reliability, data quality, they're sort of used in an interchangeable way throughout the industry. There are formal definitions, but there are different definitions. But in general, what we're talking about is the observability workflow, the alerting, the diagnostics, etc. How do you calculate your data quality scores? That's what we mean by a data quality framework. And a typical observability flow looks somewhat like this. If you were to breach your SLA, that would be an event. It would be alerted to you. You would then have to do root cause analysis, find out remediations, and it's a feedback loop that tries to figure out how to have fewer and fewer alerts, fewer and fewer issues in your data ecosystem. That's essentially what we're talking about observability. And there's a few ways, few technologies you can bring together to make that work. In our case at DoorDash, for example, I've got a screenshot of how we look at data. For each of the use cases that we have, we define rules, what needs to be met. It's a custom rule, it's a scheduled rule that keeps checking every so often. Is it a black box rule that is pre-computed for you by the ecosystems, etc. And when it comes to observability, our goal is to keep the MTTR and MTTD down, which is the mean time to detect and the mean time to resolve down. Some of the tools that are important in this area are the idea of data catalog or discovery or lineage. So for example, if you figure out that your dashboard is showing incorrect data or is not timely, etc., you'll have to figure out what are the data sets, the queries that feed that dashboard. So lineage becomes important. There's quite a few open source components out there that comes to your rescue. Amundsen was open source by Lyft. Data Hub is an offering from LinkedIn. Uber, open source, open metadata. There's a lot of blogs out there. You could leverage some of those and build data catalog discovery and lineage tools to understand that part of the ecosystem, which is the observability angle. And again, it's a question of how do you build these technologies together to form your data quality framework, whether it's a black box, whether it's integrated, is it a SaaS solution? Ideally, though, regardless of what solution you choose, try to figure out how to limit the blast radius of your data issues. Try to move the detection to as left of the equation as possible. The earlier you detect, the better off you are. The more the automated the quality detections are, the better off you are, because manual addition of rules, manual addition of expectations do not scale typically. Why is that? Because think of it from a typical SRE principle. When you're writing microservices, if you're using Java or a similar language, it's about unit testing. In Java, for example, we use JUnit testing. So how many JUnit tests do you require to get confidence that your code is reliable? In the data world, there are similar ways you could do equivalent of JUnit testing, validation rules, expectations, whatever you call it. Well, it's hard to scale that. Not that you shouldn't do it, but it's hard to scale and get 100% accuracy there. And it's a manual effort. So try to look for automated efforts. So yeah, the whole idea here is to figure out how to get the right data quality framework for your ecosystem. Okay, once you've done that, all it's about is focusing on your organizations, on your company's data culture. You got to meet with your personas, data personas, measure what matters for them, then come up with concepts such as data scorecards, error budgets, which helps you prioritize your focus and ultimately reach data maturity as an organization. So for example, we talked about measure what matters. We talked about data quality like timeliness, freshness, completeness, accuracy, etc. How do you measure them? We talked about getting agreements, SLA, and measuring as what we need to serve to our consumer community, etc. Let's focus on just one aspect of it called data quality scorecard. Imagine you got a data set. It's in your data warehouse or your data lake. When it comes to data quality scorecard, one way of measuring that is to come up with a range of score. 0 means your data quality is the lowest. 100 would suggest that it's at the highest. You could add the data quality attributes we talked about, such as freshness, null check, uniqueness, count checks, etc., into it, and with a weighted manner, come up with a score. As a representative example, in this case, it's 72.5 based on what's worked and what's failed. So based on that, you could come up with a data quality scorecard, which sort of looks like this. Once you do that, it's relentless focus on it, which is, we just talked about defining SLIs, SLOs. From that comes SLA. And from there, we got our error budget. Like, for example, if we say it's 99.9% uptime, your error budget is obviously a few hours per year. So if you're coming close to that error budget, you want to focus your team, you reprioritize your team's work on the reliability aspects of it. So it's a question of understanding your burn rate. How quickly are you consuming your error budget? If your query performance was supposed to be 95th percentile query performance, should have been in the range of 3 seconds to 15 seconds range. Well, if it's breaching that, how much leeway do you have? What's your burn rate? So if you were to do this regularly in your organization, you would you would establish a better culture. Many organizations look at it as from a data maturity perspective. You could go from low maturity, bronze, silver, and gold. A mature data product is well designed, as in eschew complex architecture for a simple architecture that does the job. It's richly described, as in everyone knows who these data sets belong to, these dashboards belong to. Discovery is important, lineage is important, etc. Is it strongly governed? Do you know where there are PII data? Are they obfuscated? Are we compliant for SOX? Are we compliant for CCPA, for GDPR, etc.? And then, of course, reliable. Are there data scorecards that that are attached to each of your data assets, such as dashboards, such as data sets, to know where you stand when it comes to a quality measure? If you were to do all of these regularly and focus on them, you get the gold medal or the gold level of data maturity. That's the holy grail. And so with that, yes, just to conclude there, focus on what measuring what matters to your end consumers. Focus on a way of describing quantitatively what your data is about. Data scorecards come to mind. Focus on your error budgets, which help you prioritize, thus gaining data maturity as an organization through Grow. So to come to look at the takeaways, understand your data ecosystem. It's all about getting to this, building trust and gaining the gold medal of data maturity. First step is to understand your data ecosystem, is to understand your personas. And then it's about defining the data contracts we talked about. And the way we get to go through this is to learn a few lessons and apply those principles. Simplification of our data pipeline architecture, focusing on the right scope, right data sets, right data assets is important. Choosing the right data quality framework matters. There's a lot of choices out there. There's a lot of ways you can bring them together. Again, while keeping simplicity of your architecture in mind, there are certain vendors, certain solutions that help you get there faster. Think about them. Big Eye is definitely a useful vendor when it comes to automated SLA formation, as I gave you a few screenshots. Focus on the data culture. It's not just about creating documents that nobody looks at. It's about actually focusing on your error budgets, on prioritizing your focus with the goal of learning from it, iterating from it, and attaining data maturity, which will then regain the trust of your organization. And that essentially is what I wanted to chat about today. Happy to take questions, either within the conference or outside, if you were to reach out to me on LinkedIn or Twitter. With that, that's my time. Thank you.